Mr. Cox. We're going to talk about space. Do you know? How do we measure in space? I know I can measure a pencil. I know I can measure a book. But how do I measure such grand scale? Well, the way we do it is by using the light year. Let's take a look. Okay, so we've talked about some measurements. How do we measure in space? It's such a huge distance that we had to come up with a unit that really we could use to measure. So we've come up with this thing called the light year. It's a huge unit, right? Because and the light year is a measurement. It's how far light can travel in one calendar year. So if we break that down per second, light can travel at almost 300,000 meters per second. So every snap, light traveled 300,000 meters, right? And what is a meter? One of these. Whoa, 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 right? 300,000 of these every second light can travel. That's pretty far, right? So if we talk about what it is in a year, right? So if we have every second, how many seconds are there in a minute? How many minutes are there in an hour? How many hours are there in a day? How many days are there in a year, right? We multiply all of that up and we get a number of 9.4605284 times 10 to the 15th power meters. Holy Christmas. What in the world does that number look like if we write it all out? 4 times 10 to the 15th. What that 15 means is that there's 15 zeros after it. So light travels 94 sextillion meters. That's mind-blowing, right? Hundreds, thousands, millions, billions, trillions, quadrillions, quintillions, sextillions. In 1 year, that's how far light travels. That's how far a light year is, right? So this is a simple illustration, okay? It shows you turn the light on, in 1 whole year, it would travel that far, okay? Numbers are a little different, but for the most part, it's right here. 9.4605284 times 10 to the 15th meters. Crazy. So we need that big, huge, large number because we're dealing with massive distances. So, what is the universe? Huge, vast, the biggest that we can get. Everything, all matter in that exists in the universe. And then we'll get smaller. So the universe is built up of these billions, hundreds of billions of galaxies, right? Well, a galaxy is mind-blowing as well, right? The galaxy that we live in, Milky Way, right? So the Milky Way is one of hundreds of billions of galaxies, right? You look up in the night sky and there are billions of stars potentially out there, and each one of them is a star in some sort of galaxy. Crazy to think of, mind-blowing to think of. But let's talk about how old it is. 13.7, almost 14 billion years old. Gotta remember, this is all in theory, right? This is the Big Bang Theory. It's not proven 100%. Believe what you want to believe. Scientists believe 13.7 billion years old. Let's take a look. Where did it come from? Just what I said. Big Bang Theory, okay? I like to call it the sneeze theory. Hey, shoot! The closer you are to the sneeze, the closer the dots of snot are. The further you are from the sneeze, the farther apart the dots are, right? The dots of snot are. So I want you to draw, what does that look like to you? The Big Bang Theory to you in this box. Ready? Go. Okay, next. This theory, at one point, it states that all matter and energy was confined into a tiny, eensy-weensy little volume, very small volume. And for one reason or another, that clump of all the matter in the universe exploded in all directions. And 14 billion years ago, that occurred, and it has been expanding ever since. Just like a sneeze, right? As you sneeze, right? Snot goes everywhere, and it goes outwards and outwards and outwards and outwards and continues. That's what our universe is doing. It's continually expanding. So we are getting further and further away from the galaxies that are around us, our neighborhood galaxies. Now that takes billions of years to do, but it is expanding. It's getting bigger. All right? We'll watch that video in class. Let's continue on. Here's an image, right? This Big Bang. Here's the center of the universe, and it exploded in all directions. So, what's our universe doing currently? It's currently expanding, right? In all directions. Galaxies are moving farther and farther apart because of this Big Bang. We started in the center, and as we exploded, we went outwards and 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 outwards. Now, do scientists believe that our universe is infinite, right? There is no limit to it. What do you think? What does that word mean? Look it up. What does the word infinite mean if you don't know? Write it down. We'll talk about it in class. No, scientists do not believe that it is infinite. There is a finite amount of matter and energy in our universe. There is a fixed amount of matter and energy in our universe. It doesn't go on forever. There's no bottomless pit of matter and energy. There is a finite amount, okay? A finite amount of matter and energy. So where did our planets and our sun and our stars come from? Right? Because we had this huge Big Bang, and this is where hydrogen and helium gas was thrown all throughout the universe and is continuing being pushed out throughout our universe. When the Big Bang occurred, it sent matter and energy in all directions. And some of the matter and energy started to clump together. Remember I told you in class, everything has gravity. Larger the object, the more the gravity. So big chunks of things started to swirl around each other, and they kind of got smashed into each other and clumped together, and then that made a bigger mass that had more gravity, so it attracted more things and it clumped together. And this gravitational attraction between two objects is what helped clump things together. So this is where the different stars and the galaxies across the universe were formed, right? So these pockets of gas and dust and debris started to clump together and clump together and clump together, and it made these clumps of stuff. Oh, crazy. Now, so we started huge, we're getting smaller. We started with the universe, now the universe was made of hundreds of billions of galaxies. What in the world is a galaxy? A galaxy is a large cluster of stars, dust, and gas that's held together by gravity. We live in the Milky Way galaxy. Milky Way galaxy is held together by the black hole in the center of it, which has a massive gravitational force, gravitational pull to it. Now, there are different kinds of galaxies. We live in a spiral galaxy. There are spiral arms that come off of the center of our galaxy. Okay? It's a flattened spiral arm. So it's almost like a disc, right? A frisbee. So if we turn it up, it looks like a pie. But if we turn it flat, it's flat. All right? We're located in one of the arms of these. We're located in the Orion Spur. Haha, Lake Orion, woohoo! The Orion Spur of the Milky Way galaxy. Pretty crazy that we can even fathom that we're right there, and we can figure that out. We're right on that arm of the Milky Way galaxy. Other types of galaxies, there's an elliptical type of galaxy, and then there's an irregular type of galaxy. So remember, hundreds of billions of galaxies really fall under three different types: spiral, irregular, and elliptical. Let's take a look at, so spiral right here. Here's a picture of elliptical galaxy. Here's an irregular. I know it's hard to see. Sorry. Google it. Look it up. Irregular. So no apparent shape. This is kind of a circular, almost a dome type galaxy. Here's another irregular one. Here's another elliptical one. All right. Moving on. our solar system. Remember, we started big, we're getting smaller and smaller and smaller. So universe, galaxy, now we are right inside our solar system. Okay? Solar system's found within the Milky Way. Milky Way galaxy has formed roughly 4.6 billion years ago is when our solar system was formed. Okay? Within our solar system, we have our sun, which is a star, and all of the planets and other bodies that revolve around the sun. So we've got asteroid belts, and we've got comets, right? We've got all of these different things, plus the planets that revolve around the sun. That entire thing makes up our solar system. Mind blown yet? All right, let's continue. Here's a picture. Here's another picture of our solar system. Right here is, this is the Milky Way galaxy. Right here is our solar system. And then we get a little bit smaller. There, boom, sun, all of our planets. We've got an asteroid belt here, and then Pluto's orbit, which is different than all the rest. So there's our solar system. Where did the solar system come from? Boom! Enter the nebular hypothesis. Theory states that a rotating cloud of gas and dust called a nebula gets denser and denser and denser. So we've got this dust and clouds of gas, and it starts with just a small amount of gas that gets denser and denser and closer and packed in tighter and tighter. So it's getting bigger and bigger and bigger and bigger. Bigger things, more gravity. Bigger and bigger and bigger and bigger and bigger and bigger and bigger. The center increases and the gravitational pull increases. This causes more gas and dust to be pulled towards the nebula. These collisions may come to the center of the nebula, and all of this because of friction, banging and banging and banging and banging and banging and banging and banging, makes it really, really, really hot. Once it gets up to somewhere around 10 million, even up to 15 million degrees Celsius, there's a trigger that starts. There's a chain reaction that starts. Hydrogen starts to fuse together to make helium. Okay? And the moment that hydrogen starts to fuse together to make helium, bam, we've got light emitting from the sun or from a star. Our sun being one of them, right? So our star was born. Our sun was born. The remaining dust and gas left from the sun was created. The remaining dust and gases left after the sun was created collided as they rotated around the sun to form the modern day planets. So when the sun was formed, right, light began to emit, and it pushed the particles, the dust and gas away, and those dust and gas started to spin and collide and smash into each other and formed the planets that we know of today. All right. Did you know, last page, did you know, our sun is ginormous compared to us, but if we compare it to other stars, it's just medium, it's just regular, it's just average. Crazy. We can see the approximate size is over 1 million kilometers in diameter. That's over 800,000 miles in diameter. So if we were to draw right, here's the sun. That's not a very good circle. Diameter, 800,000 miles across. Wowzers! So let's think of it like this. It would take 109 Earths lined up one by one next to each other. 109 of them, boop, 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 all the way across to make the diameter of the sun. The volume, it would take 1.3 million Earths inside the sun to fill it up. Crazy. The mass, all of our solar system. So we talk about the solar system. What is that again? Good. Solar system, our planets, asteroid belts, comets, all of that, and the sun. 99% of our solar system's mass is located in the sun. That means all of the rest, the planets, the asteroid belt, the comets, everything. That way we make up less than 1% of the whole mass of the solar system. Whew, that's pretty crazy. All right, so I hope this notes were entertaining to you. These are these are the space notes where we talk about mind-blowing things. All right, hope you liked it. I'll see you in class Monday. Peace out, homies.